All right. So section 5.2 again is all about compound interest. So with annual simple interest, which is what we did last time, you earn interest each year on your original investment. With annual compound interest, however, you earn interest both on your original investment and any previous earned interest. So you're compounding how much money you've earned. To see how this process works, suppose you deposit $1,000 at 5% annual interest. The following chart shows you how your account would grow. So with simple interest, if we originally deposit $1,000, now guys, something I want to stress very, very hard here is in section 5.1 and 5.2, everything is based off of lump sums. So can somebody remind me what a lump sum is? What's a lump sum?
Like the sum of all the numbers together.
In this case, a lump sum is you just put all of your money in at the very beginning. So all of your money goes in at the very beginning. In this case, it's $1,000 at the very beginning, and then for however long you let it sit. So that's what a lump sum is in the context of finance. So all the money goes in, it just sits. We're not adding more money to it. We're not taking money away from it. It's just that lump sum goes in and sits. 5.1, 5.2 are focused on the lump sum. 5.3 and 5.4 are going to focus on this idea of making payments. So that's when it changes. And of course, when we start making payments, that's when we get into things like mortgage payments and car payments and all of that good stuff. So just be super aware. And guys, if you can remember that, that's going to help you out. Milika, you're fine. That's going to help you be sure that you understand which formula you're going to be using, because that's really the hardest part of this chapter is figuring out, okay, am I using this formula? Am I using this formula? Which one am I using? Okay, so here they show us we've put $1,000 in at the beginning with a simple interest, which is what we did last time. Basically, at 5%, we're going to earn $50 every year. So we earn 50, 50, 50, 50, 50. Now, it doesn't change, does it? Because it's based off of that yearly amount. With compound interest, though, we actually start to earn more because we're earning interest on the interest that we've already made. So here, if we do 1,000 times 0.05, we make 50. But now, instead of going back to that $1,000 to start the second year, we actually pick up the balance that we currently have, which is $1,050. So we earn $52.50, and we continue to earn more and more money. So as the chart shows, simple interest is computed each year on the original investment, but compound interest is computed on the entire balance at the end of the preceding year. So simple interest always produces $50 per year in interest, whereas compound interest produces $50 extra in the first year and increasingly larger amounts in later years. Does that make sense? Is there any questions on that? If we have a savings account with a bank, do we want simple interest or do we want compound interest?
Compound.
Oh yeah, definitely. We want compound interest because we want to earn as much money as possible on our original amount. By the way, guys, what's your original amount called? I've forgotten.
Is that the principal?
That's the principal. Yes, sir. So let's look at our formula for this section. So here's our compound interest formula. We're going to have, if P dollars are invested in an interest rate I per period, then the compound amount or the future value A after n compounding periods is A equals P times 1 plus I raised to the n. I don't particularly like the way they write this formula. Let me see if they actually give us a better formula here. Guys, the way they write this formula is just, it's confusing the way they write this. Does anybody remember the compound interest formula, because here this I actually has pieces wrapped up into it that the formula doesn't talk about, and the N does as well. So for compound interest, let's actually, I'm going to clean this formula up a little bit. So I'm going to write it like this. So A, by the way, what does A mean? What did we state A was yesterday? Or Tuesday, sorry, not yesterday, Tuesday. What was A? So your book calls A the future value, but what does that actually mean in, normal terms? What's future value mean in normal terms?
P times 1 plus RT.
Mm-mm. In general, future value just means this is the money you end up with, right?
Yes.
So yeah, Andrew, you will above and beyond. So yeah, future value simply just means the money you end up with. Principal is the money you start with. So P is the money you start with, A is the money you end up with after everything's said and done. So we're going to keep the P here. We're going to do 1 plus, instead of using I though, because it's the interest rate per period. So what happens is there is an implied situation here where maybe it's not yearly, maybe it's monthly, maybe it's daily, maybe it's whatever. So this I is really the composition of your rate divided by N, and N in this case is we're going to call the number of compoundings. Your book calls in something a little bit different. They say that it's your compounding period. So we're going to let N be the number of compoundings. And then instead of using N as our exponent, and guys, you will have an exponential feature to this because it is compound interest. So we're gaining interest on the interest. Instead of writing it raised to the N, I'm going to write it raised to the NT. So instead of saying the N is the compounding periods, I'm going to say you take your number of compoundings and multiply by your number of years. So T is going to be equal to your number of years. Let me make sure I've not messed that up. Yeah. I like this formula a little bit better than the one that they're showing. So again, guys, these two formulas are the same thing. It's just the way they write it. You have to do more math to get it to be that formula. So is there any questions on that? Have you seen this formula before?
I have.
Okay. So if it's okay with you, instead of using this formula that the book gives us, I'm going to switch it up to be this other formula. Does that work with you guys?
Yes.
Yeah, I think it's going to be easier in the long run. All right, cool. So let's go do some, oh no, there's another box I got to look at or something. Let me go see what else we got to look at here. So let's go to page 359. All right, so this is what I was referring to a little earlier. Interest can be compounded more than once a year. So common compounding periods include semi-annually. We did a problem the other day with semi-annually. So that's 2 periods per year. Quarterly means that you're doing 4 periods per year. Monthly is 12, and daily is 365 periods per year. This is where they talk about when annual interest I is compounded m times per year, then the interest rate per period is understood to be I over m. So they're telling you where I wrote R over N, that's what they're saying there. All right, cool. Let's do some examples. So I'm going to go to page 365 and let's see what we can do. Again, guys, just like last time where I would write out everything that I had, I'm going to do the same thing here. That's going to be a very indicative of which formula I'm using. So we are going to start with number 8. So number 8, find the compound amount and the interest earned for each of the following deposits. So we've got $1,000 at 6% compounded annually for 10 years. So $1,000 at 6% compounded annually for 10 years. What's the 1,000 represent? Come on, guys, talk to me. What's the 1,000?
The amount that is being like the amount, I don't know how to explain it.
So that would be our initial amount, right? So that's our P. So $1,000 is our P. What's the 6% represent?
How much of that P is earning interest?
So that would be our interest rate, right? So that's our R value. So we're just trying to set up our formula here. So let's see. We got number 8. As a quick reminder here, our formula is A equals P times 1 plus R over N raised to the NT. So right now we know that our P value is 1,000. We know that our R is, what was that, 6%, I believe? R is 6%. Guys, do we ever write it as a percentage?
No.
Or you change it to a decimal.
Yep, so 6% is going to be 0.06. We've got compounded annually. So what's our N going to be? Because that's the number of compoundings per year. So what would our N be? Yep,
I
Trevor,
can't-
you're exactly right. It would be 1. So our N would be 1 because we're compounding once a year. If it said quarterly, our N would be 4. If it said monthly, our N would be 12. If it said daily, our N would be 365. So that's where the N comes into this. And then we're doing it for 10 years. So what's that 10 represent?
The T, the time.
Yep, that's our time. Yep, so that's going to be 10. So guys, is everybody okay with how we pulled that information out of that problem and why it became the variable that it now represents? Any questions on that? So now we're going to go find our actual amount. So I'm going to find my A value. So I'm going to have A equals 1,000 times 1 plus R, so 0.06 divided by N, which is 1, raised to the 1 times 10. Now, we talked about last time how it's so important that you don't round off until the very, very end of this problem. So when you go to do this, you can either work your way inside out to keep up with all of your decimals, but you don't want to round until the very end of this problem. This one's pretty straightforward to punch in on a calculator. It's really just 1,000 times 1.06 raised to the 10th. What do we get when we multiply that out?
I got 1,790.85.
That's exactly what Trevor got. Awesome. So that's going to be our A value. So 1790.85. Up. So that's the compounded amount. So remember the directions for the question said find the compound amount and the interest earned. So that's the compound amount. How do we find the interest earned? Is that really a formula?
Would it just be the compounded amount minus the original amount?
Shannon, that's beautiful. That's exactly what we're gonna do. We're gonna do 1790.85 minus the original, or what we originally started with, which was 1,000. So what's our compound interest end up being here? 790.85. That is that's not a bad amount of interest to have earned over 10 years, is it? I like that. All right, any questions on this one? Let's do another one. Let's look at number 12. So number 12, we've got $9,100 at 6.1% compounding quarterly for 4 years. So how would I do that problem? So what's our p-value? What's our p-value for number 12?
9,100.
Yep. So, and Trevor, you're exactly right. So we've got 9,100. Our rate is going to be 0.061 because we can't use percentages. We use the decimal equivalent. Compounded quarterly. What does that mean? What does that change?
You're only doing it for like a little bit of the time.
Yeah. So instead of our n being 1, what's our n going to be?
0.25, or are we gonna have to work with fractions?
Ooh, you're making it hard.
Oh,
Quarterly. So think about in the span of a year. Quarterly just means that you'd be doing it 4 times a year, right?
yeah.
So your quarterly just means your n is 4. So we've
Ah.
got much easier than what you were trying to do.
I was
Let's-
glad. I was like, if we have to do fractions right now, I can't.
Yeah, no. So here we're going to have 9,100 is our p-value. Our r is going to be, what was our rate? I lost it. 0.061. Our n is going to be 4 because we're doing it quarterly, and our time was, I believe, for 4 years. Is that right? Yep, 4 years. So let's put this into our formula here. So let me erase some of this stuff. Come on. All right. So we're going to have P equals 9,100 times 1 plus our R is 0.061 divided by our n, which is 4, raised to the n, which is 4, times t. Again, you want to be very, very careful about how you do this because we don't want to round until the very end of the problem, guys. That's going to be your biggest frustration with this. If you start rounding too early, my math lab is going to start counting your answers wrong, and you're going to be like, well, I did everything. I used the formula it's telling me. It's because you're not rounding correctly. So let me show you how I would do this on Desmos. Where is Desmos? There's Desmos. Okay, so I would, can you see my screen?
No.
Yeah, I have to do a new share here. Silly Zoom. Okay, so on Desmos, I would actually type in, so what did we have here? We had 9,100 times 1 plus, was it 0.061?
Yes.
Divided by 4. And then that would be raised to the, is it 4 times 4? I believe it's 4 times 4. So that's what we get. So by doing this, it takes all of those decimal places and it makes it a lot easier to round it off correctly at the end. You can do it by rounding first, but you have to take as many decimal places as you possibly can. So if I was to go ahead and do 0.061 divided by 4, which I actually did on my sheet of paper, if you do 0.061 divided by 4, you get 0.01525. Which means I would have to carry that number through the whole entire problem as I work. So just be aware of that. So our answer here is actually going to be 11,593.36. So $11,593.36. Now that's the compounded amount, right? How do I find the interest? So the interest earned, how would we do that? Well, I would take the compounded amount here and I would subtract from it the principal. And I would end up with $2,493.36. Ooh, I like that amount. That's a nice amount of interest earned over 4 years. That's really nice. Guys, let me ask you this. What do you think makes the biggest interest on, or makes the biggest difference on how much you earn? Is it the length of time? Is it the interest rate? Is it the number of compoundings? What do you think makes the biggest difference? What's going to make you earn more money?
Higher interest.
Avery, you're exactly right. The interest rate typically has the biggest influence on how much money you earn. But not far behind that would be your number of compoundings. The more compoundings you do, the more interest you're going to earn. Again, guys, this is just a lump sum though. We put in $9,100 at the beginning. We're going to let it sit for 4 years and see what happens. All right, let's clear this out. No, I don't want to do new share. I want to go back to let's look at let's do number 18. So the following CDs were available on www.bankrate.com on April 13th, 2013. As you can see, our book is very old. Find the compound amount and the interest earned for each of the following. By the way, what's a CD?
A CD,
Mm-hmm.
like for music.
So this would be a bank, the bank CD.
Oh, I don't know.
Anybody know what a CD is?
Yeah, it's basically when you put your money into an account for a certain amount of years and you can't use it, and then when your time's up, you can go and get it.
And
So
you've
it's a
earned.
certified deposit.
Oh, that's Shannon. I could not have explained that better if I had tried. That's exactly what a CD is. Basically, you put your money in, you let it sit. So when you put your money in, you agree to a certain amount of time that you are not going to touch your money. And then when time is up, you actually get your money back plus any interest that it gained. Basically, guys, a CD is a really low risk savings tool. So there's, you're not worried about losing your money like you would like in the stock market. So it's just a really great way to save your money. You just can't touch it. That's what sucks about it. Common term lengths for traditional CDs include 6, 12, 18, 24, and 30 months, and 3, 4, 5, and 6 years. So, it's not a super long time, but if you're worried about not being able to touch the money, then a CD may not be the best play. Anyways, even though it's a CD, it's still going to work the same way here. So we've got Third Federal Savings and Loans. So we get $150,000 at 1.15% compounded quarterly for 5 years. So that's still the same exact formula. So let's go to a whiteboard here. Let's look at the formula. Again, I'm going to label what I know. So this was number 18, I believe, right? Yes. So number 18. Our principal, so the amount that we are starting with was $150,000. Our rate was, so it's a low rate, so 0.0115. So it was 1.15%. We're compounded quarterly. So what does that mean our N is?
4.
4. And we are doing this for 5 years. So our T would be 5. So here, if we punch that in on our formula, we're going to have A equals $150,000, which I wish I had $150,000 just sitting around. We'll have 1 plus 0.0115 divided by 4, and we're going to raise that to the number of compoundings, 4 times your number of years, which is 5. Are we okay with the math behind this and how it works? So again, this is just a plug and chug. If we punch this in, we're going to end up with an A value of 158,864.68. So that's how much money we earned by the end of this. So how much interest did we earn? Because that's actually part of the question. They wanted to know the compounded amount, and then they wanted to know how much interest earned. So how would I find my interest earned? I'm going to take the amount A we got, and I'm going to subtract from that $150,000, and that's going to give us a grand total of $8,864.68. So that's the interest earned there. Questions? So we switched up, like we're looking at CDs. Doesn't change how we work the problem. Shannon, what are you majoring in?
Finance.
I figured it was finance or accounting. I didn't know which one. All right, cool. All right. Let's do a new share here. Let's try a different type of problem. So we are going to look at number 20. So number 20, find the interest rate with annual compounding. So we are compounding annually. That's really important. That makes the statement true. So $2,550 grows to $3,905 in 11 years. How would we do this? This is not like any problem we've done so far. What's the 2550? What's that represent?
That would be the initial rate, right?
Yep, that's perfect. Yes, so that's going to be our P. So what's the 3905 represent?
The number after the interest rate and the time.
Yeah, so that's going to be the amount that we end up with. That's perfect, Milika. So that's actually our A value. So let's go set up our formula here. So let's do a new share. Let's get on whiteboard. So we're going to have that our P value is actually equal to 2550. And we're going to have our A value in this case is equal to 3905. Now we know our N because they told us in the directions it was annual compounding. So our N is going to be a 1. And we know our T because they told us it was for how long?
11 years.
11 years, yeah. The one thing we don't know though is our R. So we're asked to figure out what our R is. So let's see if we can set up a formula here. So normally it's A equals, but this time I know what A is. So I'm going to have 3905 equals 2,550 times 1 plus R, I don't know what R is, over N, which is 1, raised to the 1 times 11, or N times T. So let me clean this up just a little bit more. 1 plus R divided by 1 is R, and then we'll raise that 1 times 11 is 11. So I've cleaned that up as much as I can clean it up. So here's a great question. How do we solve this?
Would you just have to solve it for R?
Yep, we're going to solve it for R. So what's our first step going to be here?
Would it be to divide the 2550?
It would. So I'm going to divide both sides by 2550. Now here's the thing though, guys, and this is what I keep stating to you about you don't want to divide too soon. I'm actually just going to keep it 3905 divided by 2550 because I don't want to have to round at any point. So I'm going to leave it just like that. So we're left with equals 1 plus R raised to the 11th power. So who remembers how to get rid of an 11th power?
This is a shot in the dark. Do you divide? Perhaps? Oh, do you square? You don't square root it.
So it's not square root. It's the 11th root.
Oh, okay. Yeah. Okay,
Yeah, so-
I was almost there. I almost had it.
Yeah. So we're going to take the 11th root here. Guys, remember the 11th root is the same thing as raising something to the 1 over 11. That comes back from our exponential rules. I'm probably going to end up writing this 1 over 11 here in a second when I go to punch this in on Desmos. So now we've got 3905 over 2,550 raised to the 1/11th equals 1 plus R. So this canceled this out.
I just have a question. So
Yeah.
when you put it into your calculator, do you have to put the parentheses in the fraction okay.
Yeah.
So you can
Yeah.
count for both, like the whole
Exactly.
term.
Yeah, because what's going to happen is if you don't put it, your calculator's only going to do, so if you do 3905 divided by 2550, it's only going to do the 2550.
Oh, okay.
Yeah, because it's obsessed with order of operations. That's a good question, Milika. To finish this out, guys, I'm going to subtract 1 on both sides. So this is the value that I'm actually going to be punching in on Desmos. So I'm going to flip over to Desmos here. We're going to show you how to punch this in. So we're going to have 3905 divided by 2550. I'm going to raise that to the 1 divided by 11 simply because I don't know how to do an 11th root on Desmos and I don't feel like looking it up. And then from that, I'm going to subtract 1. So we get 0.03950248 yada, 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 yada. The directions, they don't tell us how to round, but I think I want to say on your homework, they tell you to round to 2 decimal places, I believe. So if I'm asked to round to 2 decimal places, now this is the percentage. They want the percentage rounded to 2 decimal places. So right now, this is the decimal equivalent. How do you write the percentage? Why can't I write here? Oh my gosh, I forgot to share my screen again. You guys are probably just looking at it like, what's going on? There we go. So that's that top 10. So how would I write this as a percentage now?
$3.95.
Yep. So we move our decimal place 2 places to the right. So we get 3 point, and if I'm rounding to 2 decimal places, it would be 3.95%. So that's how you solve for your percentage. So what if you were raised to a 4th? Then I would take a 4th root. What if I was raised to a 7th? I'd take a 7th root. So that's how we undo that exponent there. Any questions on that?
Yeah, how did you get 1/11 as the exponent?
So it actually turns out when you've got the 11th root, are you okay with the 11th root, Andrew?
I guess so.
So we took the 11th root because you had, what was it? 1 plus r, I believe, over to the 11th. So to undo an 11th power, we take an 11th root. It's just like if I wanted to undo a square, we take a square root. So we took the 11th root of both sides. That's how we got the 11th root. And then I know from my exponential rules that if I have the nth root of a, that's equivalent to a to the 1 over n. So that's why I was able to write it as 1/11. Now, why did I do that? Because I don't know how to punch in an 11th root on Desmos. If I knew how to punch in an 11th root on Desmos, I wouldn't have to worry about it.
All right.
Let's see. Let's see if I can do an 11th root on Desmos. It can't be hard. Go away. So an 11th root on Desmos. That's a square. Can I put an 11 in front of it? Nope. Honestly, I don't know how to punch in an 11th root on Desmos. But anyways, Andrew, that's why I did it, because I cheated. Yeah, that's not an 11th root. I don't know how to punch an 11th root. I don't know how to do any root other than square root. I have to look it
So
up.
if you were able to do the 11th root, would it just be 3905 over 2550 equals 1 plus r?
No, equals, you have to
Square
subtract
root
the
sign?
1 of, well, you got to subtract the 1 over because we're actually solving it. There it is.
Oh, we're solving for r.
Yeah, so that's why we subtracted the 1 there. So let me go away, go away, go away, everything go away. Okay, so here if you go to functions and you go all the way down to the bottom here, you've got the nth root. So I could type that in as 11. So if I do the 11th root, and then you're going to see me type everything in exactly the same way, it's 3905 divided by 2550. Close my parentheses to say we're taking the 11th root of that, and then we subtract 1. Did anything change? Nah, because it's the same thing. So you're going to see me, I like to write it as 1 over, I like to write it as the exponential form just because I think it's easier to type in, but just because I think it's easier, that may not be easier for you guys. So you're more than welcome to type it in as the 11th root. Andrew, does that help?
Yes.
Okay. Guys, any other questions on that one? I learned something new on Desmos today. All right, cool. Let's go back to our ebook here. Where's my ebook? And I am going to go to page 360. So there's another formula I want us to look at. So we have something called continuous compound interest. So continuous compound interest is the compound amount A for a deposit of P dollars at an interest rate R per year, compounded continuously for T years, is given by A equals PE to the RT. You've probably heard this formula called PERT. Shannon, let me have a conversation with you just a second. So you're doing the finance stuff, right?
Yeah.
Do you talk about continuous compound interest?
I haven't really officially started any of my finance classes. A
Okay.
lot of the stuff I know is just from personal experience. Like I just opened a CD account and stuff like that.
Oh,
So-
you are so smart. That is so smart to do when you're young.
Yeah, so that's pretty much where I know everything. But I honestly recently just switched.
Oh, well, I think you're going to do fantastic. By the way, if you
Thank
make
you.
millions of dollars, just remember your favorite math teacher, okay?
Oh, I will.
Guys, let's talk about continuous compound interest here. So this is saying that you're compounding just every second, every nanosecond. You're just continuously compounding. Is this a doable idea? Where you're just continuous, I mean, for every moment of time, you're compounding. Is that something that typically happens? No. Continuous compounding doesn't exist in the real world because it's just we can't do it. So why do we talk about it? Continuous compounding actually makes for a great model for us to make predictions about things and to kind of see where things are headed. But again, this actual act of doing continuous compounding in the real world doesn't exist. So we learn the formula, we look at an example, but this is not going to be something that you're actually going to be able to do. You're not going to be able to open an account that does continuous compounding. Trust me, if credit cards could find a way to continuously compound on how much they're charging you, they would, but they don't. Okay. By the way, what's E? Have you guys ever seen E before? E is a number in mathematics, just like pi is. So E, as your book tells you here, is 2.7182818, yada, yada, yada. It's another irrational number. It never repeats, it never terminates. So it's just a number. So keep that in mind as we go through and do this. So we're going to do an example of continuous compounding. Again, not something that we're actually ever going to be able to do in real life, but it's a great model for things. So we're going to look at number 24. So number 24, 365. So we are going to have, they want us to find the compound amount and the interest earned when the following investments have continuous compounding. So guys, the only time I ever use this PERT formula is when it says continuous. Otherwise, this formula is never used. So it has to say continuous compounding. So again, if I label everything that I know here, on number 24, we've got $15,000 at 2.9% for 10 years. So according to my formula, which again was A equals PE raised to the RT, we're going to have A equals P. Nope. Let me write out what we know here. Stop. We've got P is going to be 15,000. We have our E is just a number, so I'm going to leave it as is. Our R, 2.9% is going to be 0.029. Our T is going to be 10. So now with all of that information, we're just going to plug it in. So we're going to have A equals 15,000. E, R again was 0.029 times T, which is 10. So I'm going to go back to Desmos. We're going to look at how to punch this in on the calculator. So let me clear this one out. Let's just clear all of these out. So we're going to have 15,000. The nice thing about Desmos is it's going to recognize E as the number that it is, and we're going to raise that E to the 0.029 times 10. And we are going to end up with $20,046.41. So our A is actually going to be 20,046.41. What's our interest earned? So how would we find that? I would take my 20,046.41 and I would subtract from it 15,000, and we would get our interest earned to be, I don't know what our interest earned is. Here, let's punch this in. $46.41 minus 15,000. $5,046.41. I could have done that in my head. I didn't need a calculator for that. Okay. Any questions so far? We doing okay?
Yes.
Again, it's all formula based. So as long as you know your formula and as long as you know what each variable of your formula represents, these are just plug and chug problems. Sometimes we got to do a little bit of solving. For the most part, it's just plug and chug. All right, let's clear that out. Let's go back to the book. Let's go look at something else here. So let's go to page 362. Okay. Let me back up a page. So we're now going to talk about something called effective versus nominal rate. So if you invest $100 at 9% compounded monthly, then your balance at the end of year is $109.38. You've earned $9.38 in interest, which is actually 9.38% of your original 100. In other words, $100 invested at 9.38% compounded annually will produce the same amount of interest as does 9% compounded monthly. In this situation, 9% is called the nominal or stated rate, while 9.38% is called the effective rate or annual percentage yield, APY. So let's talk about APY versus APR. So APR is your nominal rate or your stated rate. So the APY is the annual compounding rate needed to produce the same amount of interest in 1 year as the nominal rate does with more frequent compoundings. So let's talk about that for just a second. So a nominal interest rate is an interest rate in name only. since the method of compounding needs to be associated with it in order to get an effective interest rate, APR rates are nominal. So the compounding periods are usually monthly. So an annual effective interest rate is the time, the true interest that is being charged or earned. APY rates are effective rates. It is the true rate that states exactly how much money will be earned on interest. All right, so let's talk about what that means. Now, guys, in this section, it's really not going to do much for us. It's going to be more important when we get to the next two sections. So if APR and APY don't end up being the same thing, APY is the actual interest rate and APR is the one that is stated. Let's talk about some situations here. If we were going to buy a car, what do you think they're going to tell us, the APR or the APY? So APR is the stated rate, APY is the actual interest rate that you'll be paying based upon your compounding period. So which one do you think that they would tell us? And let me put it this way, APY is usually higher. APR, APY are either exactly the same because you're doing it annually, or APY is going to be a higher amount than APR. So if you're buying a car, which one do you think they tell us?
Probably APR.
They do, because they want to display that lower rate. So even though they show that as the APR or the nominal or the stated rate, that's not actually what you're paying, because that doesn't take into account the fact that you're paying interest on your interest. So yeah, car dealerships love to show you the APR. Now, at some point, they have to state what the actual APY is. But has anybody ever bought a car? You know, the amounts of paperwork that you're just slammed with, and they're like, here, sign this, sign this, sign this, sign this. When you sign that paperwork, you're signing off on the fact that they have shown you what the APY is, even though they may not have specifically told you what the APY is, which is the actual rate that you're going to be paying. Now, when it comes to savings accounts at banks, what do you think the bank shows you?
The APY,
Why, Shannon?
because they want to show you the most you can make.
Yeah, so they want to show you that, oh, you're going to make this amount with our bank. So they're definitely going to show you the APY instead of the APR. So does everybody understand the difference between the two? APR is just your annual rate. It doesn't take into account your compoundings. The APY does that. Is everybody okay with that idea? APY is going to give you the most accurate idea of what money you could earn in a year with a savings account. Again, we'll talk about this idea of buying cars and buying houses and where APR and APY is going to be different in later sections, because this stuff, we're not making payments. This is all lump sum stuff. Now, your book does not give you a formula for how to find the APY. I am going to give you a formula for how to find the APY. So definitely write this down, because it's not going to come up in your book. So to find the APY, it's going to be 1 plus R over N raised to the NT. Let me make sure I got that right. Let me see if I can find my page here. Nope, not the T, not the T. Sorry, guys. I got a little excited. Just raised to the N. Okay, cool, cool. Questions? So it's really just that one component of your formula. All right, let's clear this out. Let's go do an example of this. So let's go back to page 365. So they tell us on number 32, find the APY corresponding to the given nominal rates. So these are your APRs. In other words, when they say nominal rates, that's your APRs. So on 32, we've got 6% compounded quarterly. I just want to find the actual rate that we're going to be paying, or we're going to get paid if this was a savings account. So to do this, now your book is going to write this R of E. So effective rates, how they're writing that. But it's the same thing as saying the APY. That's going to be 1 plus your rate is 6%, so it's going to be 0.06 divided by, what does quarterly mean? And I still think I've left a piece out. So quarterly would be 4. This is going to be raised to 4. I left a -1 out. I knew I'd left something out. APY, let me write our formula down again, is going to be 1 plus R over N raised to the N minus 1. We have to take the 1 out to take the 100% out. It's a weird concept, but that's what we're doing. So there's your APY formula. Took me 3 times, but I got it right that time. So here, even though it says our APR is 6%, if we punch this in on the calculator, we end up with 6.136%. So it's actually 0.136% higher, the APY is, and that's just because you're doing it quarterly. So that 6% is based on annually. You start throwing in more compoundings, that effective rate changes. Do you think the effective rate would go up even more if it was daily?
Yes.
Yeah, definitely. Questions on that? Somebody's in the chat here. What's in the chat? Oh, Trevor, yes, 4. My chat box is not popping up like it normally does. Okay. So that's the effective rate. Let's move on. Let's go look at, there's another box. So guys, does everybody have this formula wrote down? You want this formula wrote down, don't, because again, it's not in your book. And it took me 3 times to get it right. So there you go. Okay. So let's go back to page something, 364. So we want to talk about the present value for compound interest. So the present value of A dollars compounded at an interest rate I per period for N periods, and they give us this formula: P equals A to the, or A divided by 1 plus I over N, or P equals A times 1 plus I to the negative N. Remember, their I is a construct of R divided by your number of compoundings. So let me write up the formula that I originally give you. So the formula that I give you was A equals P times 1 plus R over N raised to the NT. So what they're saying is, if we want to solve for P here, we want to get the present value. The easiest way to do that is just to divide both sides by 1 plus R over N raised to the NT. So that's how they get the formula. So P is equal to 1 plus R over N raised to the NT. Or you could write it as a negative exponent if you wanted to, because it's the same thing. That's an exponential rule. So that's the formula. That's what your book is trying to tell you. Remember, they use I and N as something weird. They don't show the whole entire formula. They don't want you to do this math in your head, and I don't want to do that. So there's the formula. Questions on that? Let's put it to use. So I want to go look at number 36. So number 36, they give us, find the present value of the given future amount. So on 36, we've got $8,500. So that's the future amount. That's my A value. So we got $8,500 at 6% compounded annually for 9 years. So let's clear this out here. Go to a whiteboard. So again, our formula was P equals A over 1 plus R divided by N raised to the NT. So on number 36, they told us that our future value, or A, was going to be 8,500. They told us that our R was 6%, so 0.06. They told us that our N, so we're compounding annually, so our N would be 1, and our T would be equal to 9 years. Guys, do you see now why I want you to write what we know out? Does it make sense why we write it out? What do you think the hardest part about this next test is?
This.
Well, it's just knowing which formula to use, because every section that we do has a different set of formulas. So I think by the end of it, we've got like some crazy amount of formulas, like 8 or 9 formulas that we have to know. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 formulas. There's 11 formulas by the end of this. So one of the things that students get confused on is, I don't know which formula to use. So that's why we write what we know down, because the more I can figure out what we're looking at, the easier it is to pick which formula we're using. So you always want to get in the habit of doing this. So if I plug in what we know here, we're going to have P equals 8,500 divided by 1 plus 0.06 divided by N, which is 1, raised to the 1 times 9. So this becomes a punch in the calculator type deal. Guys, please remember that if you're trying to use an actual calculator instead of like Desmos, this needs to be in its own set of parentheses. So you need to have a big set of parentheses around the bottom just to say, hey, make sure you do all of these calculations on the bottom before you go through and divide. Is everybody okay with punching this in on the calculator? Do we need to see it? I'm going to take silence as no, we're fine. So here, if you work this out, you're going to get P is equal to $5,031.14. Trying to think here. These are like the same problems over and over and over again. let's do. Let's look at 44. 44 is a different take on him. And I can only imagine how much more depressing this is going to be when they update this book. So number 44, so assume an annual inflation rate of 2.07%, which is not the inflation rate right now. This was in 2012. So we're asked to find the previous price of the following examples. So how much did an item that cost 7,500 now cost, or 7,500 now cost 5 years prior? What are they asking us to find here? Which one of those variables?
P.
They're actually asking us to find P. Yep. So with number 44, we are going to have so we know our A value is going to be 7,500 because that's what it currently is. Guys, I can only imagine what this is going to be today. We know our R was 0.0207. Was it 2.07? I think it was. Our N is 5. And this was our annual interest rate. Yep, annual inflation rate. So our no, let's see, 5 years. Sorry. This is going to be our time. 5 years is our time because we're doing it for 5 years. It was 5 years prior. And our N is going to be a 1 because we're doing it once a year. So here we're using that formula that we just looked at. So we're going to have P equals 7,500 over 1 plus R 207 divided by N raised to the N times T. So if we punch this in and we do the math and we work it out, we end up with so that $7,500 item, and this was in 2012, that $7,500 item in 2012, 5 years prior, so in 2007, cost $6,769.72. What do you think that item costs today? So 10 years later than this. So if an item costs $7,500 10 years ago, I'm going to guess probably 10,000 today. Not sure, but it's prices are ridiculous. Inflation is ridiculous. So there we go. Guys, any questions? I did not get completely done with section 5.2. I was hoping I would. There's a concept that we have to go over. We're just not going to have time to do it today. So we're going to call it quits on section 5.2 for today. On Tuesday, when we come back, we will finish section 5.2 with a discussion of logarithms. I know, you're going to be excited. And then we'll start into section 5.3, which is where we start seeing us making actual monthly payments and all that good stuff. So I will see you again on Tuesday. Have a great day.
Thank you.
Have a good week.
Have a good day.
Bye.
Thank you.
Hello,